So, good morning, everyone. I would like to welcome you today. This is the fourth webinar. We'll be talking about the mitigation solutions as part of my ArcClash 2022 series of webinars. Bit about me. So, my name is Marcin Nuta. If you don't know me already, my name is Marcin Nuta. I run my own company, EMEA PowerTech. But before that, I used to generally work as 10 years already as a power system engineer, doing power system studies in electrical systems, but overall 15 years in electrical engineering. So if you would like to know a bit more details about me, go have a look on my LinkedIn profile. It's quite up to date. A few words about the webinar for today. So I try to keep webinars under 30 minutes, plus minus. Then we have a 15 minutes Q&A session, but I will keep answering until we run out of questions or we run out of time from Teams, which I think is limited to 60 minutes. If you can do me a favor and write questions in chat box or Q&A box, would be perfect for me to find it later. And as you see, I'm recording this and I will be uploading this webinar to YouTube channel as previous one. So you can share with your colleagues that couldn't attend, or generally I will share it with everyone else. So what I plan for today. So the main topic today is ArcClash mitigation. I will explain a bit what it is. And we will go through overview of the solutions that we can do. I will then go through some examples about the most common solution that I know and I use. And of course we have a Q&A session, which is I think the best part of it. So let's go for it. ArcClash mitigation. It sounds like something hard, but in practice, if you are aware about this, and if you're not about this slide, then maybe you should watch my previous webinars, which are on the YouTube channel. But because I will just jump into this topic straightforward. So when we do the ArcClash study, and ArcClash mitigation is part of ArcClash study, I put a lot of focus on recommendations. And recommendation in brackets is mitigation part. So we'll provide existing calculations, and then once we have it, we will go to the results and review it and provide recommendations and improvements. And those recommendations and improvements are actually utilizing all the mitigation solutions that we might have. So that's what we are looking at. We go into the hierarchy of controls in NFPA 70E. That you will find out, at least this thing. And if we do ArcClash study, we will focus today actually for the elimination, substitution, engineering controls. I know that there are also few of them, like awareness, administrative controls, and personal protective equipment. But for PP, I have a separate webinar actually, and I would say it's straightforward. So I will mention about it later. And administrative controls are, let's say, soft way. So we focus today on hardware solutions. And that's the idea behind it. And if you do ArcClash study, you should have it in general included, cover those three. Let's go and have a look what we can do. I make this as an overview. So to answer how we can reduce or eliminate ArcClash in our system. Sorry. The first and the most important part is our current settings improvements. So behind this, the idea behind it is that we will review all the settings of the protective devices and review of course ArcClash results and try to provide recommendations, or provide recommendations for improvements. So we still need to remember about the selectivity and proper protection, but sometimes and very often actually it's easy to provide improvements, and this is cost-effective solution. The next thing, and I will talk about it. Next thing, very similar to this one, is current limiting fuses. So if your system is mainly made with fuses for protection, you might have a look on current limiting fuses. Not all fuses are current limiting. That's why I have it here. And they will significantly reduce the ArcClash energy. I would say the next step or next solution might be ArcClash relay, which by ArcClash relay I mean the relay because it looks like protection relay that has a detection system, so fiber optic sensors, pressure sensors, light sensors. it will detect the arc and also has a voltage or current, or voltage and current criteria to distinguish what kind of fault we have. Also, this system might be expanded to arc quenching. So it might be on medium voltage and low voltage system, but arc quenching is a expansion of the system with quencher, which is switching off device, which is actively switching off arc flash. And I will show you an example later in more details. There is something called adaptive settings, special scheme for protective devices. This is a very specific topic, but sometimes the systems are complicated, like in data centers. When you have a communication, you have multiple configuration of the networks, and it might be that your relays will be programmed in the way that they will adapt to the network configuration. This is just a very simple explanation, but that's more or less what it is behind. That the relays will be reprogrammed online or live as we switch off, switch on something. A very specific topic, I would say. Maintenance mode, so ARMS, depends how you call it. It's arc flash reduction maintenance switch or energy reduction maintenance switch. It's mainly the function of low voltage breakers, ACB breakers, and especially the trip unit of the breaker, not the breaker itself. And we'll talk about it. I will show you an example. Zone selective interlock. This is a nice feature to have. The name is for the low voltage systems, which is generally protection based on communication between the breakers. Very interesting topic. Actually, it's very often included in the modern digital relay, digital trip units of the low voltage breakers. And the same thing you might have in the medium voltage relays, which is called protective relay blocking scheme. More or less this way. Very similar concept. Differential protection, very fast, but requires some attention when we try to use it for arc flash, because it will not detect everything, but it's nice to have. We can also lower the likelihood of arc flash to happen. And if I will go step by step, I should say that improved skills and proper maintenance are the most common and lockout tagout. But let's go step by step. Panel IP level, which is ingress protection. We try to keep at least in the of the level IP2X for internal protection. I will show you an example on this. Higher panel separation forms. This is internal separation form of panel, and I will discuss in details what it is. Proper maintenance, of course. I think recently there was a publication in UK about how important it is to properly maintain your medium voltage breakers to avoid catastrophic accidents. So yeah, that's important. I would say maintenance. Please do it. You might improve your design. And by improved design, I mean the design of your system. So when you are in the design phase, of course, not every configuration of your system is effective, especially for safety. So you might work with this a bit more. But as well as a hardware design of the panel itself. For the panels, when we talk about the switchgears, we might have internal arc classified switchgear for medium voltage systems under IEC 62271-200 for IEC world, but there's also NC code C standard for it. We might have low voltage switchgear as well. It's a different name. It's not internal arc classified, but I think it was used to called arc resistant. Now it's I think arc rated. Doesn't matter. It's the same concept. Under technical report 61641. So you still can build the low voltage switchgear, which will be resistant for internal arc. Of course, lockout tagout, very important to de-energize, but also to lock out the energy. So this is, I think it's now included in NFPA in EN 5010 as a basic method. And of course, improve skills. Improving skills, it's, I would say, probably 20% of 30% accidents. But in general, it's good to have very knowledgeable people that works around the such installation like electrical installations. We might increase distance. This will be under engineering controls if we look on the hierarchy of controls, but I think this is easier to understand it this way. If you have your panel and your system, it might be operated by SCADA system, which is remote operation. You are just sitting in the control office when you switch things. You might have motor operated breakers when you operate system like remotely. Only you have to remember that it's pointless to have motor operated breaker when you are standing in front of it and operate it from the front panel of this breaker. Then you have some kind of like the control tablet or control screen when you were somewhere in the substation, but let's say a few meters away. Safety switch is a very nice feature, to be honest. If you would have to manually switch something or electronically, I think part of it will be now also, you might switch things via Wi-Fi or Bluetooth, which is very interesting feature because we have all hardware with us as a smartphone. Remote racking solution. So if you have a lot of ACB breakers, air circuit breakers, and you have to rack it in, rack it out, which means we have to physically put it inside the live into the place where it belongs. Sometimes it's good to have remote racking solution. So some kind of device like this will be remotely racking in, and we are just standing a few meters away. And all infrared scanning inspection windows. Of course, there are some limitations for them, but it's very nice to have. Like a permanent thermal temperature monitoring system is also nice things to have. It's not on the list, but it's a similar concept to this thing. What else you might see? So I'm aware that there is a current limiting system from ABB called IS limiter. It's up to 40 kV, 40.5 kV. We will not discuss in details, but it's part of current limiting. And as far as I remember, it was used mainly, not mainly, but I remember in projects when I had was in marine systems. Current limiting reactors. Specific topic is just to check, but it's not that if you install it, it will solve your problems, but it might be used as a solution to lower the energy at some point, but you need to check it. Short circuit reduction, I have it separated because it means that you might configure your system different way. Instead of operating 2 or 3 parallel transformers, you might operate 1 or do it a little bit different way, split your loads. And absence of voltage tester. I drop it here because I like it. It's a specific topic, but it's very interesting because every time you isolate something, you need to check the absence of voltage, so prove that. And this is interesting because you don't measure anymore, you just validate it. But it has some requirements and behind it, but it's a very interesting feature to have. So if we talk about the switchgears, and I mentioned about the inner arc design, mainly in Europe we will refer to IC 62271. There was new release last year, and I will show you a video what this means. It's easier. The same for the low voltage. So to the guide for testing assemblies under arcsync. But important to remember that behind all the internal arc classification and hardware related to switchgear, it is associated with the fact that design of everything is done for the normal operation or normal switching operation. So if something happens inside the panel, it has to stay inside. We'll show you videos. But you have to keep in mind that every doors and the covers that has to be secured, they have to be secured. And otherwise you might lose this arc classification. There was a new release for 2021 red elevation for the high-speed earthing switches, which is used actually, as far as I know, also for ABB and Siemens. And there is new standard for IEC 63107, which is integration, like what we do now, integration of internal arc fault mitigation system in power switchgears and control gear assemblies. And it follows the design for the switchgears. So just to give you an example what it means. So when we talk about the internal arc test, if you would like to see the past one, that's what it is. Those are tested by KEMA in Czech Republic, as far as I remember. It's very nice to see it because you see in slow motion what's happening. I actually like it. It shows, especially in slow motion, you see that there was a venting opening And this is how it looks when you fail such test. Yeah, it's straightforward. You don't have to be engineered to see that this is not okay. But if you look in slow motion, you will see that, yeah, the arc was not confined inside. So you don't have any internal arc classification. The next thing, so that was about the hardware design. It's this is much more complicated topic. Sorry for skipping this, but it depends on what kind of brand you will be buying and what the levels they have. Generally, there's a lot of effort to design, then there is a test to prove it, and then you have to validate if you are in the range of this validation. So if it's up to 16 kiloamps 1 second, you have to be up to 16 kiloamps 1 second. That's part also about the arc study. When you do it, you also validate this point. IP cover, so ingress protection. This is probably the best thing you can do and the easiest thing and cheapest thing you can do in your switchgears and to increase your safety, not only for arc flash but also for shock hazard. So we try to recommended to keep IP2X or X2 level, so finger safety, and there are multiple levels of IP, whatever you would like to do, from nothing to water immersion, but I will show you how it looks in real life when I go on site. So, and those are from projects when I collect the data. So on the left side you see that, okay, this is okay. There are some covers here, but then you open it and you see main breaker with the cable connection and the main bus bar. So this is very bad from shock hazard point of view and is also increasing the arc flash likelihood to happen. So generally, if you open the doors, you have energized parts. So you need to have all your PPE. On the other hand, so recommendation would be to put the cover, plexiglass on it and to cover it, so you cannot touch this thing. On the other hand, you see on the right side, despite it looks not that nice, here this cover is very functional because it was covered from all sides. Here, from the top, from this side, it's very hard to grab something, accidentally at least. What I maybe add is just to move the hose in front instead of back, because if something drops here, it will fall down on the bus bars. But still, this is much better solution. With the covers, when we talk about the covers and separation, we have form of separation. This is topic when you order or design your panel. There is internal separation, separating the breakers from the supply, from the bus bars, and so on. So typically, probably you will see 2A, 2B, and 3B, and I think 4A forms, but all of them are possible. I will show you an example what this means, how it looks like in practice again. So if you travel, and this was one door just to open, and you see this. So you know, okay, there is no form of separation. It's like form 1 or 0. You can grab everything here. You can touch everything here. It's generally it's bad. And on the other hand, that was the same place. On the other hand, you have this, and I didn't have to open it actually to collect the photo. That's why I don't have a photo inside, because the breaker was accessible, the front of the breaker, and everything else was closed. I didn't have to open it. And to be honest, but I would expect that there will be a cable connection, which is actually going from the top. There is a control panel, control part of it, compartment. It might be, it should be separated from the bus bars in this place. The breaker, if you open, you see it's not easy to open it. So probably if you open it, you have to see the bus bars, everything else. Sometimes they have a covers in the front. And then some, I think this is supposed to be control compartment. But if you see 3 doors, you might expect something like 3A, 3B level, as a rule of thumb. So common solutions. So I show you generally overview, but I will go in step by step to explain you what we can do and how I did in the project. So this is from the real project I did. I just changed the names, took some part of it, where we have a medium voltage switchgear, we have a transformer, low voltage switchgear, and then the panel board downstream. And most of the time, and I would say 90% of projects will use overcurrent protection, maybe maintenance mode if that's applicable or not, because that depends what kind of hardware we have, and arc flash detection systems, arc flash relays. And in this one, it was, I think, data center, we had this. So just again, question, but you will not answer it. I'm not asking you. So where you will typically expect highest energy, and in medium voltage, low voltage, or panel board? And I can answer you that yeah, it will be on the low voltage panel, especially on the incoming side of the low voltage panel. So the same side of the transformer, low voltage side of the transformer will be probably the worst one as well. But this is rule of thumb, it doesn't have to be this way. There is one thing that I have to explain before we go further to the results. So something which we call concept between line and bus side. Just very briefly, because I think I explained it before. There is a connection, cable connection, you see 7 cables per phase, and there is outgoing and the main breaker. So everything up to here is protected by the medium voltage relay upstream. There is a main breaker, and then everything after the breaker is protected by this breaker here. So we have a location which is not really protected by this breaker inside the panel. This is called line side or supply side or source side, depends on software you are using. I use for this one SKM because it's a historical project, so we'll follow this one. Again, we have existing situations, so just to give you a reference point, we have a base. I use this to drop your results, and you might see time current curve. So this is graphical way of showing protective device settings between medium and low voltage. You see at utility we don't have a data, so it will stay like this, 34 calories. We have a 10 kV bus, 18 calories. We have a low voltage breaker, which is now 90 calories because of the incoming side. We have low voltage panel, which is 20 calories, which is quite high, and then we have a panel board, which is 1.24, which is almost on the border of Akfash 1.2 calories level. Still, this is not very well done from selectivity point of view, so we will improve it as well. So let's go. The first one is overcurrent settings. That's the easiest thing we can do. And I improved the settings. Again, this is the real project. I improved the settings from the medium voltage, from the low voltage to make it selective, also a bit faster. And just doing this, we drop from 90 to 19 calories here. So that's the huge difference. From we cannot work, probably then, yeah, we can do something. From the X1 is this one. So low voltage panel drop from 20 to 7, which is also a huge difference. Panel board will not change most likely all the time. The medium voltage stays the same because we don't have a data from upstream. But the 10 kV bus after improvement also dropped from 18 to 4, which is also a huge difference. So that's only when we play with the overcurrent settings. This is, we play with what we have, and that's how far we can go, at least to this level. Probably we can tweak it a bit more, but that was, let's say, reasonable level. Again, I said about the maintenance mode, so arc flash reduction switch, energy reduction switch, how it works. So it works very simple. There is a switch inside the trip unit. We can activate it or not, or deactivate it. It's supposed to have a lockout tagout feature also as a, let's say, cover here, so no one can change it. But it works in the way that for the time being that we are in the substation, we are doing something on live equipment, it will bypass the settings to the minimum level. We always have to check it because it doesn't always work. For us, it works this way that we drop the settings to the barely minimum. So it should still operate. But for us, our safety was more important at this moment. And yeah, that's it. But we lose selectivity in this way because you see this is not selective anymore with the downstream breakers. So there's something for something. I did the same, you don't see it here, but I did the same like the programmed arc flash reduction switch for the medium voltage relay as well. So that's why you start to see the difference and explain me why. I don't know if you see the difference, but I changed the settings of the medium voltage relay and you see the change settings of the low voltage breaker. This gives us the changes from, because the only thing will change is the line side of the low voltage switchgear and the low voltage switchgear itself. So now you see the drop from 7 to 2 calories and from 19 to 8. So that's still a significant difference for us, and we still utilize what we have. Maybe we have to change the trip unit here, depends what's possible. The next thing that we can do, and that was for this project, there was an arc flash detection relay to use. At least I was recommending this. So the arc flash detection relay works in the way that it has a sensors for it will detect the arc flash, but detects the light, detects the pressure, depends what kind of system you have. Also have a voltage and current system to detect what's happening. And then it sends the signal to low voltage breakers, depends on your network configuration, also to the medium voltage breaker as well, because we would like to protect this line side and transformer. From operation perspective, this is supposed to operate under 5 milliseconds, typically is faster 3 to 4, and plus we have to add the breaker tripping time, which might be something between 50 to 120 milliseconds if this is medium voltage breaker, few cycles. It works this way. I think that's the best explanation. This is the video from Schweizer lab of their own system. Again, slow motion is the best one. Yeah. I hope you can see it step by step. So you see the pulsing when it's 500 milliseconds instead of 50 milliseconds. And that's why we use it. So we try to make our time much shorter. And when we use the arc flash detection system, it's a separate system, so we still can maintain the selectivity. So you see, I revert back to the settings we had before in the scenario 2, but now we have a separate system that is monitoring everything and is stripping also medium voltage system. And you don't see it again, but I also did the same for the utility breaker to protect this one. So that's why I see 1.12. The difference now is again that we compare it with the scenario 2. So instead of 7, we have 2 calories, and instead of 19, we have 3.55. So that's the difference on the breaker itself. What else we can do? So that's, let's say, overview of the scenarios we did for the project, but in practice, we can also extend the system, arc flash detection system, with the quenching device. So then we have arc flash quenching system. It's the same story, just we send a signal to the device which is called quencher. The way how it works is easier to show you, but the way how it works is it make 3-phase fault on the bus bars very fast, under 4 milliseconds, 5 milliseconds, it has to be very fast. Then it creates the 3-phase fault, and in the place of fault we have no voltage or very limited voltage, reduced voltage, which means that arc cannot sustain because there is no voltage in the system in this area. And then we have to send the signals to trip energy because our system can withstand the 3-phase fault, bolted fault, but not the arc fault. So the best way is to show you this. That's how it looks like without quencher. Yeah, that's what it is. And if we have a system activated, we try to do the same. That was test from EPH test lab in Berlin. And there is one thing that I would like to put it here aside. It calls the same name. So we have arc flash detection devices, which are from some time already mandatory in commercial installation, depends on the country you are in. It has similar name, but it serves different purpose. So you see word arc fault, arc flash, but it's something different. It's I pick one from ABB because I like the way how they make it, just to give you an idea what it is. So we use it in the commercial buildings, but the purpose is different. Because the energies are usually small enough, it will not, of course, if you grab it, it will make you harm, but it's not the risk for you from arc flash point of view. It's very big risk from fire point of view. And those systems are designed in the way that will prevent the fire in commercial installations. And they do it significantly. So, yeah, and I like this video actually from it. It's explained it very well. I don't have to add too much to it. The difference is that the arc flash AFDD, arc flash detection device, has electronics inside. It looks similar, but it's not the same thing. So it has electronics inside that is monitoring the voltage and current, and it's trying to detect the disturbance that is correlated with the arc fault, with this arcing that's happening. Yeah. I think it's just self-explanatory how it works. And I thought it would be nice to add it here just to give you an idea that this is on the end consumer unit level, which is very interesting from a fire prevention point of view. And again, as I said, it's not that it's just the electromechanical device. There is electronics inside it's monitoring and actually trying to verify if we have an arc flash or we start the drill or something or motor. So it is very good and doing this. So that's all for today. As I give you a short summary, I would say like consider any solutions in design phase, because sometimes you will not be able to add things later. You might have a new switchgear that will not be able to expand things. Consider IP cover is a very cheap solution to do, and it's not only protecting against arc flash, but also, which is more important, about the shock hazard, about the electrocution situation. So consider this, pay attention to details, especially on the study level, but also on how you execute things, and verify technical possibility for improvements. So before we jump into conclusions that we have to do something, we need to be sure that we can physically do it. It is part of the after discussion that we always have after projects, but just as a summary. So what else you can also do? As far as I said, you can identify the protection areas which are most important. So if you have the results from the study itself and recommendation, then you might focus on something specific now. Sometimes, and actually very often, we check for possibility between selective operation and arc flash safety. As a simple explanation, sometimes things it's hard to make selective, but we make it better from arc flash point of view, much faster. And once customer is aware about it, he said he might accept it and live with this, I would say, this way, until the next improvements. We might limit access locations to only authorized personnel. So when we have a high energy and we are afraid that someone will go there and hurt himself, generally, this is general rule of thumb in Europe, but just to consider this, okay, it's a limited location, limited access. And of course, if we cannot reduce energy or eliminate energy below 1.2 calories, we will use PPE. And this is part of the solution. Just we try to do everything before we jump into PPE selection. And as you've seen on the very beginning, we had 90 calories and we can go down to almost 3 calories, which is a huge difference. And for PPE, I decided that I will make a separate webinar about it, just to explain the details. So that's all for today. The next webinar will be about the more detailed example about the project I did where we use actually arc flash mitigation techniques. So from the project perspective. So I invite all of you for it. It will come in May. Still, I think 7-8 webinars to come. And now we have a time for Q&A session. So I'll be happy to read your questions if you have any. So let me check if I see something. Nothing here, feel free to ask. Explain about ERMS, RMS. What I can come back actually to the slide. Let me check this. So ERMS, that was this slide. So it is called arc flash reduction maintenance switch. The idea behind it is that we have a breaker equipped with a digital trip unit most of the time, and it has a specific maintenance mode function, which is off-on only. It can be activated or deactivated. Sometimes there is a separate button. And so the purpose of this thing is that we will bypass settings, instantaneous settings and short time settings to make breaker act as much and as fast as possible. Because we are there, we are doing some work, maintenance work, and we say, okay, instead of having like here, instead of having 12 or 10 calories, we would like to have 2.2. So it means that we are better protected, we have less energy. We might use different PPE, depends what kind of change it is, because it might drop from 40 calories to 20 also. So for the period of time, for us, our safety is more important than selectivity in the system. So we can sacrifice selectivity, make the breaker not selective, but very fast. And because of this, we will reduce the energy on the part of the system behind the breaker that we are working on. And depends on manufacturer, of course, but it works very similar way. So we still have to operate our system. So if you have some 2000 amp, 3000 amp load, we still have to keep it. So this will not change. The only thing that will change is the short time and instantaneous settings. And we don't do it. We just, the way how it works is just, we just activate it off or on, and we don't change any settings on the trip unit. That's the idea behind it. And we then normally take it as a separate scenario in the AFDD calculations, and you might print a separate label for this kind of operation mode as a warning on the on your switchgear. So I hope this explained the topic, but it is a bit more complicated to show. So it's better to show it on specific examples. Why differential protection sometimes won't be the best solution. It's not that it's not the best solution. Differential protection is a specific topic which of course costs you something. So if you have a low voltage switchgear with differential protection, will be very unusual to have, to be honest. So it's more in the medium voltage systems, very often for transformers. And the point is that sometimes you have a maybe resistor grounded system with limited current, which might be under the reach of the differential protection. So this might happen as well. So I would say the differential protection for me as a solution would be somewhere on 4th, 5th, 6th place, where I know that we, for example, have to protect the transformer better, maybe generator, and it gives you extra time, less time. So if you have it 100 milliseconds or 50 milliseconds diff protection, then comparing to 400 milliseconds typical overcurrent, then we take it into account for the study. So if you have diff protection, it's very nice. If you plan to have it, it's still better. Also, sorry, there was a follow-up question to the arms. I didn't catch it. Whether it should be on or off to reduce. So it should be activated on. Depends how you call it, active or not active. It has to be clearly marked what is doing this switching position. So if you take it arms on, off, on means it will be reduced energy, off it will mean that everything works normally as it's supposed to be. Can we adjust these settings remotely, for example, before entering the electrical room? Yes, actually it makes sense. That's how it's sometimes done. There is a separate switch on-off, like 22mm switch on-off, maybe control panel, which you can, when you just, for example, enter substation or enter station, you might activate it, lock it, and when you are entering, you already know the energy is lower. So if you have a remote option, that's very nice. Sometimes it's just on the doors of the switchgear, but still you can do. It's not a big thing, but it's much better when you have it into some other place. We'd like to hear your experience on arc-flash energy exposure calculation mitigation on DC systems, UPS 400, 240 VEC or 120, 24. Yes, I have, and I have to prepare a separate webinar about the DC arc-flash because I had multiple projects from data centers with battery banks and also generally DC arc-flash itself. So you still can mitigate it. Very often it means, at least so far as far as I see it, for the DC arc-flash, very important is more configuration of your protection. So where you put your protection physically. I would say the best way is to keep it very close to the batteries. So it has a chance to eliminate one bank of the batteries and switch it off. it makes also change if you have a parallel system going to, for example, to the UPS unit, or you have a combined system that it goes to the common DC bus and then to the UPS systems. So those kind of topics I already had in the last few years in DC or data center projects. So thanks for reminding me. Have previously used relays with multiple settings groups and switched to activate a different group via digital input. I think if this was a question from Darren, yes, I did, and did a few projects like this in my Eton times, but also now, where so generally depends on the relay you have. Relays give you, the better relays will give you some ability to program multiple groups of settings, which can be activated by remote control. It might be digital by ISA 61850. So you just digitally will reprogram the relay. Of course, you have to test it before, but you might do it this way. And this might be also linked to the configuration of the network. It might happen automatically, or it might happen via SCADA system, or it might be activated by some switch. So there are a lot of options for it. I would say that I previously, depends what is the purpose for it. Is it protection behind it, but also, or maybe arc flash? Then it means that it's better to use lockout tagout switch that you can physically lock, or it just reprogramming digitally is enough. So that's very interesting topic. I would say it's quite fresh, and combined with the Goose messaging and ISC 61850, which is for me, we did. I remember there was a few data centers like this we did, and it was very interesting. Also challenging, but very interesting to have. Yeah, thank you, Franz. What else we have? What about arc flash releasing duct located on the switchgear? I assume that you mean that there is a arc flash venting system or arc flash release system. So when you design the switchgear, like low voltage or medium voltage, part of the hardware design and simulation is that you create a part of the switchgear able to open, or sometimes there is some kind of arc coolers, how you can call it. It is venting back the pressure and generally the energy pressure outside the switchgear. It might be outside of the building, it might be to the cable chamber. Generally depends what you have possible in your switchgear substation. So yes, it is part of the internal arc classification design, it's part of arc rated design. I think it's column comment about the adjusting remote settings. Okay. What else we have? I'm looking on the question as Indian, so we look on the chat. What I might add to the remote operation in general is that you see there are a lot of solutions that we might have. It's not that there's only one or two. It's not that the new switchgear will solve everything. And again, I will make one webinar about it because we have I had one interesting project when everything was exchanged, but eventually it was like copy paste from the old system, so nothing really changed besides that you have a new switchgear. So all the results were actually bad, and we have to improve it and solve it. And when you look on the remote operation, you have to keep in mind that it's not that we cannot go to the panel and do something. We can do still normal switching, and this is part of likelihood of occurrence of arc flash, but also about, and FPA says normal operation is allowed. It's not a big issue. Sometimes we might go through risk assessment and say, yeah, we don't want to do it still because we are a bit afraid of it, but that's a separate topic. Question from Jerome. Regarding the maintenance mode of CB enabling arc flash mitigation, I believe that the certification body has to approve the solution. I guess because this affects the overcurrent protection of the electrical system. Not that I know. Certification body will approve, for example, the breaker and type approval, but it has nothing to do with the protection. So you adjust your protection based on your system. Depends what the system is. what kind of transformers, breakers, motors you have, you are building your electrical system from the certified elements. And depends what you mean by certification body, but I mean, I have in mind something like DECRA, or I have like electrical 5 years electrical tests. So to be honest, you might check, but no one will really answer you probably this question this way as you think. So my answer would be no, it has nothing to do with this, at least in my feeling. The only thing behind it is that when you do arms, you need to clearly mark what you did and what it has the influence of the system. So it is overriding the tripping unit, and everything is in the manual of the trip unit that you are buying. And all the main manufacturers, they have it now. And the difference behind it, that maybe that's the reason why, because we reduce the time. So we go from the, let's say 400 milliseconds, we go to 50 milliseconds. So this is the safer way of doing. It's not selective, but this is our problem as an end user, that we operate system not selective. I can tell you that I have a multiple project when systems are set on default settings. No one was checking. Even they go through 5 years electrical safety measurements, everything else. No one see this. So to be honest, legally it doesn't have nothing in common with this. It's my feeling. Have you calculated arc flash exposure with the doors closed for medium voltage switchgear before? You mean doors closed or doors open? Because normally you calculate as a door closed. So that's the typical stuff. And I can tell you, my colleagues from Eton, they have this. I cannot use it because it's the patented thing, but they might calculate based on their FMEA calculations for specific switchgears. They might calculate the pressure inside the panel and the building. I think we call it arc pressure calculation or something like this. But normally you treat all the calculation for arc flash. If the doors are open or closed, generally we treat it as a closed. So we don't differentiate, at least yet, we cannot differentiate between open and closed doors. I know there is a difference on pressure relief, but it's very complicated to calculate it as well. And as a rule of thumb, if you operate the system, and I can show you the videos, sometimes it doesn't matter if the panel is closed, sometimes it doesn't matter if it is open. I think behind it is that when you operate it, you always do something with it. So probably it's half open, half closed. It's hard to predict this. And I think it's, I saw it in Australia, I think, somewhere, that the approach to try to show the difference between open and closed doors, but or in Sweden as well. And in my feeling, at least, it is a bit risky to say, because it very depends on the hardware design. Like all the hinges in the doors, is it screwed? Is it open, half open? Is it fully closed? It's a very specific topic, which I think the NFPA is on the safe side now, and IEEE 1584 as well, saying that we don't take into account open or closed doors. We treat them as generally as an open. But generally you can, if you refer to box and open arc or box test, it's generally, you can select this. You can use it as a factors in your calculation. What is? All switchgears designed in accordance with IEC standard, which doesn't require additional PPE for operation in country. Is this correct understanding? Well, actually, no. So, as a rule of thumb, you might say that everything requires PPE, some sort of level. Is it arc flash PPE, electrical shock hazard against electrical shock hazard PPE? It very depends what you are doing. Now, if you are measuring something, if you are just making a switching operation on off, and so I can say, okay, everything designed according to IEC is supposed to be safe, and that's fine, that's okay. Then we add to this next layer, we calculate what is the arc flash level, and now you might say, okay, my switchgear is designed according IEC, but also ARC rated according to 61641 technical report. So we know up to 15 kiloamps, 300 milliseconds, the ARC will stay inside. And then you say, okay, whatever we operate, and everything is normal operation, whatever we operate, things happen inside and they stay inside. So we don't need any additional ARC flash PPE for doing our work. But as well, you might have a normal, because 99 on 100 switchgears on low voltage they will not have any ARC rating. So, or they will be partially. So let's say on the other side, you have a switchgear, which is normal, typical low voltage switchgear, let's say 2500 amps. You are going to operate it, let's say on off, but you know that you have 40 calories or maybe 30 calories per square centimeter energy. So if you look deeper into NFPA 70E, NFPA has a very nice table which is called likelihood of occurrence of arc flash, and it will tell you that for normal operation, like switching on, switching off, or switch breaker contactor, you don't need any additional PPE if everything is in normal condition. And they state what is normal condition. On the other hand, they also added last revision that if you did any maintenance on your switchgear and your equipment, especially on the breaker, and now you are going to energize this. So after bigger maintenance, let's say, they consider this as a higher risk, and they will tell you that, yes, you need to have your PPE now. Despite that this normal operation, it's a bit higher risk to do. Because if something will go wrong, it will go wrong in this way. And I can add to it one point. You need to prove that. So for example, if you switch off things, then you have to measure. And for measuring, you need to have a PPE, because we consider this as a live equipment still. So you might as well have PPE for switching off and then measure. So I hope this explains your question. As a rule of thumb, it's just having IEC. It's not doesn't mean that it's safe from ARC flash point of view. I see there's also ongoing discussion with Callum, but let me have a look. Downside of maintenance mode is that you still rely on someone turning it on and off as needed. Some room for human error to occur, but usually cheaper to implement an ARC detection system. Well, idea behind it is also that you have a lockout toggle. So you are the engineer that is going there, switch off things, you activate it, and you lock it with your lock. So there should be no one else activating this because it's on your breaker that you are working, let's say, in. So you have to do it step by step by yourself. Oh, we still have 5 minutes left. As a comment from my side. Yeah, you can always use light indicator. This way you know if your maintenance mode is activated or not while entering the switch room. Again, it depends how it's designed out. Recommend to have lockout, tagout, and clear switch on off, so you see the position. You don't have to do it on the breaker. You might, but you don't have to. And as Jerome said, you might also have the clear light saying, yeah, it's activated. So I hope it explains. There's a lot of nice questions. Unfortunately, Teams has some limitation for such meetings, so I think we are running out of time. Oh, I see one more question. Maybe I can get it. Is it recommended to have arc flash monitoring devices to review asset conditions and any potential arc flash coordination? I don't know what you mean by arc flash monitoring device. You mean arc flash relay? Because they will not review you conditions. They will just react to what's happening. But you might drop me a more detailed question, then maybe I don't understand it very well. Let me switch off recording.